नमस्कार मित्रांनो. Today we are going to learn applications of BJT. First application of BJT, which is commonly we are using everywhere in a speaker system, sound system, that is amplifier. So what is mean by amplifier? The amplifier is a circuit to which increase the magnitude of the input signal. So if input signal is small, we will get its amplification and we will get output signal as a large. Okay, so see here, this is a circuit used as an amplifier where R1, R2 creates biasing circuit. Capacitor C1 and C2 are used as a blocking capacitor. They blocks DC. Okay, we are giving input as a sine wave, and you know IC is equal to beta IB. So when currents start flowing from base, we will get current flowing from collector also. Okay, the relation between collector current and base current is IC is equal to beta IB, where beta varies from 20 to 200. Okay, so now what is the output over here? Output we are measuring at this collector point, and it is nothing but VCC minus the drop across RC. So output voltage is equal to VCC minus ICRC. Now what happens here? In a positive half cycle, as IB go on increasing, your IC also increases. Okay, so IB increases, your IC also increases, and therefore this drop ICRC will also increases, and as a result we will get output less because the more voltage drop will get subtracted from the VCC. So output we will get on the negative side. Okay, and in a positive cycle, as IB increases, the output voltage comes down. When IB goes to the negative cycle, what happens? Your ICRC drop will go on decreasing and your output goes towards the positive half. Okay, and that's why you will gain 180 degree phase displacement from input to output. The voltage get amplified here. Okay, if you see, the magnitude of input voltage is less than magnitude of the output voltage. So output voltage will be more than input voltage, but the cycle will get reverse, or there is a 180 degree phase shift. So that is my first application, amplifier. Second application of BJT is a switch, that is a simple on and off circuit. So whenever we want to keep this circuit off, here V in will be negative signal. Okay, for example, this is the input signal. This voltage is minus V1 and this voltage is V2, that is plus V2. So we are giving minus V1 up to time this T1. So what will happen? This part, VB part, will be reverse biased. Okay, reverse biased. VBE will be reverse biased. And what will happen? As this is reverse biased, no current IB will flow, no current IC will flow, and the BJT will work in a cutoff region. It will act as a open circuit, and the output whatever we are getting here will be VCC. So output will be V0 is equal to VCC. Part, that is from T1 to T2, you are having forward bias circuit. So VBE will become forward biased, and your VB is also forward bias, your VCE also forward bias, and this will run in saturation region. Maximum IC current will flow through the circuit, and we will get output as equal to VCE. So whatever voltage available at these 2 points, we will get as a output VCE. So for certain duration we are getting, that is cutoff region, it is remaining off, we are getting VCC as output, and when it is short circuited or it is turning on in a saturation region, we will get output as a VCE. The last application of the transistor is oscillator. The very important part in oscillator is tank circuit. What is tank circuit? Tank circuit is the combination of L and C in a parallel. Okay, so it is very much required to create the required frequency. Okay, because you know L and C both are charging elements. They are getting charged for some time, after some times they are getting discharged. So while charging and discharging, will create a cycle. What is mean by exactly oscillator? Oscillator is a device which gives you oscillatory output. Though we are providing constant input, we are getting the changing or oscillating, like your example is sine wave or triangular wave. These are the forms of oscillatory output. Okay, so here we are taking output from the RL where IC comes, or the IC which is available will go up and down. So output will be IC into RL, which is due to the charging discharging cycles of this L and C circuit, we will get the change in the current flowing through this RL, and that's why the output nature of the system will be oscillatory, or it is varying continuously with some frequency. This frequency can be decided by the values of capacitor and inductor, that is L and C. If you change the values of L and C, you will get the change in frequency. So as per the requirement of frequency, we are selecting the values of L and C. So these are all applications of transistor. In next video we will go for FET. Till then, thank you.